Welcome to our exploration of map projections. And not just map projections, but all of the different pieces that go into map projections, from understanding the shape of the Earth to translating that into a generic shape of the Earth to translating that into a map projection. The whole flow, we're doing everything in this sequence, broken up into a few parts as usual. Give you a chance to wrap your brain around it. Remember, this is your brain on geography. Any questions? Or maybe your brain is nicely folded out like the Dymaxion projection from Buckminster Fuller, easily showing interconnections between land on the planet. If you fold it another way, you can see interconnections between the oceans. However we slice it, or however we squeeze it or pull it apart, map projections are the foundation of our two-dimensional maps, with all of the struggles and distortions and everything else that comes with them. So we're going to dive in. We're going to talk about these topics in order throughout these videos. I'm going to start off just reviewing a little bit of X, Y, longitude, latitude stuff, because I think it's really important to re-emphasize. We discussed this a little bit in the last module in a previous set of videos, and one of the things we talked about was this is a map of the Earth, the easiest map of Earth you could make. Two lines, one the equator, one the prime meridian. And one of the things we discussed is that certain hemispheres have certain sign conventions. So if you're in the northern hemisphere, your latitude is always positive. If you're in the southern hemisphere, the latitude's always negative. For longitude, if you're in the eastern hemisphere, your longitude's always positive. And if you're in the western hemisphere, your longitude's always negative. Good to remember, good to emphasize. So if you're collecting data and you know which hemisphere you're in, you can kind of check yourself by following this progression. However, this convention, latitude, longitude, latitude, longitude, latitude, longitude, latitude, longitude, for each of these things, is actually opposite how we would refer to things in graph space. Ever graphed a plot, made a graph, you're very used to X, Y. What's the X value? What's the Y value? And what is at issue with how we say latitude, longitude versus the tradition and the common usage of X, Y is that those don't actually match. Longitude is X, latitude is Y. Latitude is measuring progressions above or below, north or south, positive or negative from the equator. And when you've got graph paper Earth out here, oh wait, yeah, that means latitude's the y-axis. So we say latitude, longitude, but when we say that, we're saying yx. You encounter this in Lab 5 at the start, though ArcGIS does most of the work for you. And whenever you're inputting x, y coordinates, if you have them labeled as latitude, longitude correctly, Arc can read that, your GIS can read that, and set that up for you correctly automatically. But if things aren't labeled correctly, then you have to remember this. Latitude is Y, longitude is X. So when we're saying lat long, in graph space, we're saying YX. Latitude changes with Y. Longitude changes with X. Now we're bound, unlike this graph space here, which theoretically, these graphs go on forever. Just keep extending the axes up or down or left or right. We are bound on our planet by the maximums that we have for these different values. And this is really essential when we're working with geospatial or any kind of spatial data, really, that might not be well labeled or might not be, perfectly metadata, any of the problems that we can experience in GIS, because our lat-long space, our graph space is constrained. We cannot have more than 90 y degrees. No more than 90 latitudes, no less than negative 90 latitudes. Our graph is constrained to a maximum y value of 90 and a minimum y value of 90. Longitude's the same, just to the 180 line. We cannot have more longitudes than positive 180 or less than negative 180. So we actually draw bounds on this graph. So unlike these graph spaces here, we actually have boundaries. There is no 92 degrees north. It doesn't exist. But thinking of the Earth as a sheet of graph paper is not the worst way to think about the Earth. And it's not the worst way to think about coordinates. And it's not the worst way to think about transitioning the three-dimensional shape of the planet to 2 dimensions. But you have to remember that longitude is X and latitude is Y. And when you get that locked down, all this coordinate stuff makes a lot more sense. Think about that for a bit. Check in on you next time.